Good morning guys, Anjani Kumar here, leading Power System 2 for third year electrical students. Till now, we have successfully completed our second unit regarding sag, tension, insulator. Alright, today I am going to deal about the brief review of total unit. Alright, I hope each and every student following these videos that are prepared by each and every faculty members. Right, I'm suggesting you guys definitely should follow, because you don't know each and every faculty facing lots of troubles while providing these type of videos during lockdown period, right, for your technical improvement, right? I know that each and every students are very busy with their works, and I'm asking you guys at least once at your free time you should see the videos. Definitely each and every faculty must satisfied about their work. Right? Okay, in this session I'm going to a brief review of what I completed until now, Unit-2, and basic introduction about the next unit. Alright, in the last sessions, right, previous sessions, we discussed about what is a sag. So we started with sag, tension and insulator. The concept is we discussed about what is a sag. You know about sag. So what is a sag? Sag means the distance between top of the tower to the lowest point of the conductor, so we can call it as a sag. And we discussed about tension, right? So tension is nothing but stress on the conductor, right? So it is nothing but a force to move the electrons or move the voltages, right? Tensile strength is there, right? So conductor, we can place a transmission system between the two towers. How you can erecting the transmission system between the two towers? So that's an important point, right? So you can place your conductor in a two ways. The first one is a loosely connection and tightly connection. Right? Each and every connection that it has some advantages and disadvantages. If the conductor that can be placed between the two towers in a tightly connection, so definitely the conductor materials will be saved, the cost will be reduces, the first point. And the second point, ground clearance, right? Ground, we don't want to go for a high towers, because if you connect it tightly between the two towers, we should have a proper ground clearance, right? And the disadvantage is tension. When you are connected tightly, the tension will be very high. That means the force from one tower to another tower, and one more tower is there now, from that tower to another tower, the forces are equal opposite forces. So what happened? There will be a breakdown occurs in a conductor. So if the breakdown occurs in a conductor, there is a loss of power. So that is the disadvantages when you connect it tightly. And remaining are all advantages. The cost reduction, ground clearance, no need to go for high towers. Alright. So if you connect it loosely, a transmission line between the two towers, so there will be an advantages and disadvantages also. So what is the disadvantages? Definitely the conductor material required, it should be very high now. So when compared to the tightly connected, so we should have to maintain a proper ground clearance. That means you require proper height based towers. And one disadvantage is there is a less tension. So there is a less chance of breakdown occur between the two towers. Right, between the two towers at the transmission line, there will be a less chances of breakdown. So we need to combine these two lightly and tightly connected systems. We should have a proper sag and tension calculations we need to take. So if you want to build a transmission line between the two conductors, we need to maintain sag and tension must be within the limits. Right? That's why we need to take care while erecting a transmission system. The sag and tension must be within the limits. If it crosses, definitely there will be a breakdown, or else the conductor material should be very high. Like this, these are the things, ground clearance, right? Height of the towers, these are the things that will get. So we should make that sag and tension must be within the limits. Alright. So what are the factors that affecting the sag? We discussed, right? What are the factors? The weight of the conductor, right? If the weight of the conductor increases, your sag also increases. Alright. The place where your transmission line is erected, like it's like a cool places, there will be a ice loading around the conductor, so definitely the weight also increases, the sag will be depends on that. And the length of the conductor, length of the span is nothing but the distance between the two towers, or else the distance of a transmission system, so we can call it as a sag, we can call it as a span. Definitely your sag also depends on the length of the conductor. Alright, sag is directly proportional to square of the length, and it is inversely proportional to the tension value. If a tension is very high, what about the sag? Sag will be reduces, right? Right. If a tension is increases, your sag is going to be reduces. So these are the factors that are affecting the sag. So we already discussed. And if you want to erect a successful transmission system, we should maintain the sag and tension must be within the limits. So definitely you should calculate what is the sag value. So sag we can calculate it with the help of two basic things. So what are the things? There will be a two equal height of the towers. If you take a two equal height of the towers, what is the sag value? Right, unequal weight of the height of the towers, what is the sag value? We discussed and derived the formula for each and every equal weight and unequal weight of the unequal height of the towers. Alright, so for equal weight of the towers, what is the sag value? Sag is equal to WL square by 8T. So W is nothing but the weight of the conductor per unit length, L is nothing but length of the conductor, T is nothing but tension existing in the conductor. Right, so from that from the equation you will see whether the sag is affecting or not. So sag is directly proportional to the weight of the conductor, directly proportional to the square of the length of the conductor, and inversely proportional to the tension existing in the conductor. So these are the factors that are going to be affects the conductor. If you take unequal height, like hilly areas, if you go for hilly areas, one tower bottom of the hill and another tower is the top of the hill, definitely there should be in that places also we need to maintain a sag value. So for this we derived a formula S1 S2, right? We discussed all these things. And definitely one more condition that we take when wind and ice loading on the conductor. So definitely one more factor, like cool areas like Canada, right, Norway, these are the cool places. In that places, if you erected the transmission system, there will be ice around the conductor. So definitely ice around the conductor means the weight will be changes. So sag must be depends on the weight of the conductor also. Alright, so there will be two forces acting on the conductor. So the weight of the conductor which plays in a horizontal direction, and wind force which works on the vertical direction. So the net weight will be square root of W plus Wi whole square plus WW whole square. W means weight of the conductor plus ice weight. It should be work horizontal direction, and weight of the wind should be a vertical direction. If you want to find the net weight, so we should take the value of W is equal to square root of W plus Wi whole square plus WW whole square. Right, we derived that formula and we discussed about each and every weight individually. Right, after that we solved some problems on different heights sag calculations, right? And when wind and ice loadings happen, so what is the sag value? No, these things that we discussed successfully, no doubt about that. After that we discussed about definitely the successful operation of a transmission system must be depends on what type of insulator that you are going to take. So that's why the insulators are different types. Alright, so what is meant by insulator? So insulator means the insulator is a device which can which can eliminate the leakage current, whatever the currents from the transmission line to the tower and to the earth. So if you won't provide in a proper insulation between the conductor and the supporters, definitely if any person touches the tower, definitely will get a severe electric shock. So that's why we should maintain a proper insulation between the conductor and the tower. Alright, so the successful operation of a transmission system depends on what type of insulator that are going to be chosen while erecting the transmission system. Right, there are four types of insulators out there. There are pin type insulator, alright, suspension type insulator or a string insulator, right. After that, strain insulator and Shockley insulator and egg insulators. These are different categories that we discuss each and every insulator in detail with the graphical representation also. So what is a pin type insulator? So insulators are made by porcelain. So definitely there will be another materials also, because there are depends on temperature variations, but porcelain doesn't melt with temperature variations, right? So that's why always we prefer porcelain material while choosing the manufacturing of these type of insulators, right? And what is a pin type insulator? The name itself indicates like a pin model. Alright, there will be a frames out there, porcelain frames, disc frames. On the top of this we can call it as a groove, where the conductor is going to be twisted there. Alright, the bottom which is connected to the cross arm, and it will be connected to the tower. Alright, and what we discussed, and this type of insulator that can be used for a distribution system that is nothing but less than 33 kV. Alright, so if you used greater than 33 kV, it will be more economical. Alright, so what are the failures happen in a pin type insulator? There are two types of failures that are going to be happened in a pin type insulators. The first one is the flashover, and second one is the puncture. The flashover means the porcelain disc is there now. These are smoothly surface area. So if you have to maintain the surface area will be very smooth. If it is a rough, means the dust particle will be stay there. After some time, after a period of 1 year or 2 years, all the dust particles will be stored there, and it will make a conduction path. So when the current from the groove directly enters to the dust particle and enters to the cross arm, and it will enter to the pole. So definitely when a person touches the pole, he will severely electrical shock. So this type of phenomena we can call it as a flashover. So what is a puncture? Puncture means there will be a defect while fitting your groove. There will be a cracks around left and right side of the disc. After 1 year and all these things, the disc will get damaged. Directly the current from the groove to the cross arm, and it will enter into the pole. So definitely when a person touches, he will get severe electric shock. So this phenomenon we can call it as a puncture. Flashover, it will take more time, but a puncture, it will take very less time when compared to flashover. So we just need to take care while designing these type of pin type insulator. So for this we require a safety factor. So what is the definition of a safety factor? Punctured by flashover voltage. If you take this one, so while designing your pin type insulators, right, that is very, very important. So what is the safety factor for a pin type insulator? Is nothing but 10. So these are the things we'll discuss in detail. After that we'll go for a suspension type insulator. The suspension type insulator which can be used for greater than 33 kV. So that is nothing but a transmission system. So we can use these type of transmission system like a suspended, right? So suspended on the bottom, we need to connect the conductors, on the top which is connected to the cross arm. We discussed in a graphical representation also. After that, the each and every disc is represented by 11 kV, right? If the line is carrying more voltages, we need to insert another disc at each and every disc from the suspension insulator itself. You can tell whether the system is carrying how much voltage. For suppose there are 6 discs, means it is carrying 66 kV directly, you will say. Alright. So these are very, very advantageous, because it can be used for greater than 33 kV anywhere. Right, if the problem occur on any one disk, you just remove the disk and insert another disk. No need to change all the insulator materials, right? So that is very advantageous. After that, we'll enter into the strain insulator. The strain is nothing but a stress. So while river crossing, dead ends, right, landing points, there will be a stress on the conductor. So we need to avoid that stress. We need to introduce a strain insulator, right? So the suspension insulator that can be horizontal. The strain insulator is nothing but a suspension insulator, but it can be placed in a vertical conditions, right? Vertical levels, right? If stress is even more, we have to make these type of strain insulator that are connected in a parallel, right? So I clearly explained. For a low voltages also, you can use these type of strain insulator. Those type of insulator we can call it as a Shockley insulator. Shockley insulator, right? After that, we'll enter into the Shockley insulator. Shockley insulator, it can be used for less than 11 kV. So it's like a distribution system, like which is fitted to the pole itself. From that, the conductor is going to be taken. So we have seen all these insulators in detail, right? After that, enter into the potential distribution over a suspension insulator, right? So definitely the suspension insulator plays a predominant role while erecting a transmission line, right? You will see that suspension insulator, how the suspended string is there, right? If only string is nothing but each and every disk is nothing but a capacitance that we discussed. If only the self capacitance exists in the system, definitely the current flowing through the total string will be the same. That means the voltage across each and every string is uniform. If the voltage across each and every string is uniform, we don't have any problem. Alright, there is no damage to the string. But the string suspension disk, suspension string, and the pole, between these two, we have another capacitance. So that is a shunt capacitance. This plays a predominant role. Right? These type of, if a shunt capacitance exists in the system, so what happened? The current in the string which is not equal. That means the voltage across each and every disk is not uniform. Right? That means whatever the disk which is nearer to the conductor, which is having a maximum stress, right, and goes on, the stress is going to be reducing. So that means the chances of failures or a puncture near the conductor is very high. So if it's got damage, total string will get damaged, because the conductor carrying disk damages means the total string will get damaged. So we need to protect that string insulator. How we can protect? So if it is a pin type insulator, we need to go for a safety factor to protect the system. But if you enter into the string insulator, we need to take in care. So how you can maintain the voltages at each and every disk is a uniform? So with the help of string efficiency. Right? So what is a string efficiency? The string efficiency is defined the total voltage across the string by number of disk and the voltage nearer to the conductor disk. Right? We clearly explain what is a string efficiency. If a string efficiency increases, that means we are providing uniform voltages. Right? So we discussed each and every disk voltages. So how you can find out what is the voltage, what is the V2 value, what is the V1 value, right? So what is the V2 value, what is the V1 value, what is the V3 value. After that, V equal to V1 plus V2 plus V3, right? V2 is equal to 1 plus K into V1. So what is the K value? It is a shunt capacitance by self capacitance, right? And V3 is equal to V1 into 1 plus 3K plus K square, right? From that we derived all these V1, V2, V3 and all these things, right? After that we calculate the string efficiency, and we know that if a K value is going to be reduces. So what about the string efficiency? If a K value reduces, that means the shunt capacitance is reducing. If your shunt capacitance is reducing, definitely you are eliminating the shunt capacitance. So that means so if a K value reduces, means your shunt capacitance is reducing. If a shunt capacitance is reducing, definitely you are eliminating that shunt capacitance, means you are providing the voltage across each and every disk is a uniform. So that means you are improving the string efficiency. That is a very very important note. After that, second note is the voltage nearer to the disk, which nearer the conductor disk, which is having a high potential. So it's our aim to maintain the voltages across each and every disk. So better. That's why we introduce a string efficiency concept. And very very important situation, that how to improve the string efficiency. Right, there are three methods to improve the string efficiency. If you take a longer cross arms, the shunt capacitance will be very less. So you are avoiding the shunt capacitance means your string efficiency is increasing. You are avoiding shunt capacitance means the current in a disk is current in a total string is equal. If the current is equal means whatever the voltage across each and every disk is uniform. Right, the first method. After the second method is a capacitance grading. Right, different graded capacitance. If you take in a string, definitely capacitance is inversely proportional to the voltage, and the lower part which is nearer to the conductor, which is having a less capacitance, it can withstand high voltages. Being this, you can increase your capacitance level. That means you are taking different capacitance. It's a cost-based issue. Definitely we protect. We can maintain the uniform voltages across every disk, but it's a costly-based issue. Or else, and it will be very difficult for you to tell whether the conductor is carrying how much voltage. Right? These disks are very different. That is one of the disadvantages that you will get with the help of capacitance grading. And one more important concept is a guard ring. If you provide a guard ring between the metal sheath and the cross arm, there will be another capacitance which is between the string and the guard ring. So definitely these shunt capacitance and the guard ring capacitance will be cancelled out, and there will be a current in the string is uniform. So if the current is constant, that means whatever the voltage across each and every disk is a constant. So these are the three methods to improve the string efficiency. Right. So these methods are very very important when you go for GATE and IES exams. Right. So whatever the string voltage will be always the phase voltage, not the line voltage. Always you have to take the phase voltage. So what is the relationship between the line and phase voltage? Line voltage is equal to √3 times the phase voltage. So these are the notes that we discussed, and we solved 2 or 3 problems on this string efficiency concept. So these are the unit concepts that we discussed. Right? I hope each and every students have a minimum basics on what we discussed till now. Right? I hope it's clear. So if you have any doubts regarding this unit, you feel free to call me, and definitely I'll respond, and definitely I'll give whatever the questions. I'm ready to give you, right, whatever the questions and all these things. Right. So this is about the sag, tension and insulator concept. Definitely you'll get a question on sag calculations and different types of insulators. Right, they can ask they'll ask any one insulator, just explain and all this, and what is the string efficiency. Definitely you'll get a problem on string efficiency, and what are the methods to improve the string efficiency. These are important questions. Right, if you follow my videos, definitely you don't need to prepare all these questions and all this. Right? You just follow my videos, that's it. You just directly go to the exam and write. No need to by heart, no need to prepare another time and all these things. Right? So this is about Unit 2, and in the next session we are going to discuss about third unit. Till now what we discussed means what are the different types of a transmission line. So what is a transmission line? What are the different types of a transmission line? Short, long, medium transmission line. And the next unit we discussed about what is the relationship between a pole, how to erect the transmission line. So you need to take in care while constructing a transmission system, transmission line and the pole. We need to take in care like an insulator, right? We need to take in care of a sag, a tension and all these things. What type of insulators, what is the string efficiency, all these things we discussed. That is nothing but erecting. That means we are we are placing. Right now, in this unit, we are going to discuss about what are the factors. Now the transmission line over we are connected to transmission line, the current is going to, the voltage is traveling. So while traveling that voltage, what are the factors that are going to be affect in a transmission system? So that's we are going to discuss in coming sessions, right? What are the factors, various factors that are affecting while the voltage is traveling in a transmission system? There will be a 3 or 4 effects in the system, so we need to take care of all those effects. Also, these effects are very, very important for your competitive exams. There will be a skin effect, there will be a proximity effect, and corona, right? All these things, right? So we need to take with clear explanation from the following sessions, right? I hope it's clear, right? I hope each and every student should follow these videos for better understand. And thank you for now. In the next session, we'll start another unit. Right? Thank you very much.